you
Hey.
Ross?
Yeah.
Okay, I'm Katie. I
Oh,
was
you're
emailing
Katie.
you earlier today.
Yeah.
So if I can't switch in on Tiger Hub, do I need to like, who do I talk to like do that? Because I know like for grading assignments, you have to put like your preset.
Yes. So you should always put down the preset that you're officially enrolled in. But you're welcome to attend.
Okay.
Yeah.
Awesome.
As long as you fill out my surveys, and then I can send you
Yes.
stuff after the fact.
Okay, cool.
Like debrief with solutions,
Yes.
whatever. But yeah.
Okay.
Yeah, you're totally welcome to it.
Thank you.
Yeah.
Deal. Thank you. Thank you. Have a nice weekend.
Yep, you too.
Oh wait. Where's Lisa?
What's going on
here? Attempting to do a live stream.
Oh.
I don't know if it's working.
Oh, that's weird.
Let's find out. Never done this before.
Get out of the camera.
Unsupported resolutions. Let's fix that. All right, we'll get started in just a minute. But meanwhile, if you go onto Piazza and you go to our post about the workshop, you can find a link to the materials in a Google Drive that we'll be using today. And there's the main event. Hey, Lisa.
I was jotting down notes.
Oh, cool. That'll be good. Yeah, I mean, you're pretty much ready.
Okay.
The live stream is supposed to be working,
Okay.
I think. Here, yeah, hey.
I'm gonna try to feel like every CEO ever with their iPad.
Ooh, with notes? Wow, okay. This is gonna be top notch. Oh yeah.
Oh god. Yeah. Trying to
Cool.
like mentally cope with the fact that my face is gonna be on the video. Oh.
Oh, go away.
Oh
That's
god.
what you do all the time.
Oh god. No.
You do it every preset.
Oh
Just
no, but it's
without
different.
cameras.
The internet never forgets. Anyway.
All right,
Okay.
should we do it?
Let's do it.
Cool.
Okay.
All right, hello everyone. Thank you for coming out to the 226 debugging workshop. My name is Ross,
I'm Lisa.
and Lisa's gonna start us off.
Okay. Cool. So everyone checked yes on this, right? Yeah, okay. Where is your IntelliJ?
No.
Okay. So, let's get started. I wanted to start off with a little bit of motivation before we get into like the nitty-gritty of IntelliJ. So, I think the most important thing to keep in mind is IntelliJ is just an assistive tool. it's up to you to really understand your code and to really use IntelliJ more as like a, what's a good analogy? Like, you know, Bob the Builder could build houses with his hands if he wanted to, but it's even better when he has a hammer, you know? Like, this is your hammer instead of using like a very vanilla text editor. Okay, that was a weird analogy. It's okay. So you absolutely can print out things if you want to, but today we're going to highlight some more interesting things that you can do with IntelliJ. Okay, so we're going to keep coming back to these two main points today, which is one, how do I expect my code to behave? And two, does my code behave that way? And then everything else, every tool that you see in between is just to assist you in that process, that iterative process. Okay, so let's first take a look at these two classes, bank and account. So we tried to create a example that felt like real life. Okay, so bear with me. In your account class, you have some notion of how much money this account contains. And you can initialize it with 0 funds, which is not so fun, or you can initialize it with monies, which is more fun. Okay, and then you can do things like deposit money into this account, and you can also withdraw amounts into your account, from your account. And you can also check the balance. There's some very like vanilla unit testing done here, not necessarily sufficient, but we'll come back to that. So
I actually have a question. How many of you have seen this syntax where you have multiple constructors in a class? Okay, who's unfamiliar with this?
okay, yeah. Okay, that's great. So the idea of having like multiple constructors is very similar to, for instance, if you were to construct a method with the same method name but different method signature. Does method signature like sound familiar to anyone? Can I see your hands if it does? Okay, cool. So notice here, this constructor takes in no arguments. So if you were to do like new account, open parentheses, close parentheses, you would be initializing an account object that executes in this way, which is basically setting an empty balance. If you were to use this other constructor with some int amount, similar thing, it would just execute this block of code. So now you have an account object with some non-negative amount. Does that make sense? Okay, cool. Okay, so now let's move on to the bank object. A bank contains a list of accounts, and its only constructor is like, we create a brand new bank. We have all the accounts ahead of us. We can add accounts, and we are going to assume that all of the accounts are unique, so no pointers to the same account object. And we can also retrieve those accounts and return it back to whoever cares about this bank object. And the fun thing that we're going to focus on is some notion of a balance across all accounts, which is just summing up the total balance that this the accounts that this bank has contains. Wow, that was like a really like roundabout sentence, but does that make sense? Who nods? Yeah. Shaking? No? Okay, we have nods. Okay, great. So some notion of balance across accounts. This is an iterative implementation, and we also have a recursive version of this. Has anyone seen like recursion done this way in Java? Stare at it for a couple seconds. Kind of. I see one nod. Other nods? Okay, so the idea here is, and I think that you guys will do this in one of the later assignments, but main idea is I want to do this iterative thing recursively, and I need to do so by having an overloaded method. So the helper method that I'm going to use to recursively calculate this balance is going to sum up all the account balances from index I all the way to the n. So for instance, if I were to do balance across accounts recursive 2 with some already prescribed running sum, it could be 0, or you could like assume however much you want for this initial running sum. It would sum up like the account at index 2, and then plus the account at index 3, plus the account at index 4, and so on, until it hits the end of the list. Okay, I'm gonna take a pause and see if anyone has questions about these two classes. We comfy? Yeah, oh yeah. Hi.
What does it exactly mean to calculate the total sum across the accounts recursively?
Okay, so if you think about what the iterative version of this function of like balance across accounts does, you're basically reassigning and modifying instance variables in a single environment, right? But when I do so recursively, I'm opening new environments and adding it to my stack. And then once I have this like final tallied up version, I pop environments off my stack, and then I have my final answer. So the process of like summing these things up, it's like very similar to the iterative version. You're just using more space to open up environments. Does that kind of make sense?
Does it mean that you're modifying the instance variables when you're using the iterative method?
Oh, sorry, not instance variables. I guess variables in your current environment. So here I'm just.
So you're modifying balance.
Yeah, you're modifying balance within the same environment, whereas this, you don't have like, what's it called? I mean, I guess you could do like an instance variable thing, but that's a little bit weird. I'm gonna move aside that thought. But you have to have some like running notion of like cumulative balance, right? So the way that we have that like cumulative balance is by keeping track of it in running sum. And then this I is basically, well, if I wrote this like for loop a little bit differently, it would be the same I that we use to index into the list. Yeah. Okay, other questions? Yeah.
Why separate like those statements, like, I mean, the methods, like why is the balance across accounts recursive that takes 2 units, not just its own method that calculates the sum? Why is it different in the public?
Yeah, so, okay, if you, let's say that we didn't have this private method, right? We still need some way of like keeping track of the cumulative sum that we've seen, and it's really hard to do so because this like public method doesn't have any like input arguments that would help us keep track of it. But having those, alternatively, if we removed this method and just kept a method with this signature, like whoever is using this API, they don't really care about what running sum I have, right? They just want to know the balance across all of my accounts. No arguments. So this is for the client, and this is for your use to keep track of the running sum and which index you're at. Ooh. Ask questions. Keep going. No? Is that okay? Okay. We'll circle back. Okay. Did you have a question? Okay. Yeah. Okay. Feel free to stop. Stop me at any time. Did I see another hand in the back, or was that like my imagination? Okay. Okay. So I'm going to really quickly start introducing you to the magical functionality that is the IntelliJ IDE. So let's first just activate our debugger and see what happens. So in my main, I have a few like tests. I'm basically just expecting a few things, but don't worry too much about what the tests are for now. Let's just try to use the debugger. So the way that you get to it, you would right-click on whatever class that you're working with, and then you can either run it with arguments or without arguments. In this case, we don't have any arguments that our main takes, so I would say debug, baked.main, and it looks like nothing happened, right? I'm just printing out things. How is this different from just running it without arguments? Well, the debugger will execute every single line of code in order until it hits a breakpoint. Okay, we don't know what a breakpoint is though, right? Okay, so if you go over to any one of the line numbers, and then just to the right of it, click, you'll have this like little red thing. That's a breakpoint. Okay, so I'm going to put a breakpoint on line 70 and 77. A breakpoint's purpose is just to say, hey, debugger, you've seen this line, don't execute it yet, just pause for a moment. So now, when I try to run the debugger again, I can also run it by clicking on this little bug, which is like fun. Ooh, it's a bug. Okay, so if I rerun this debugger, now it's going to stop execution, pause execution before executing line 70. Okay, so I just want to point out a few things that this debugger will show you. It'll show you what's happening in your environment as is. So right now, notice that I can see what args I passed in, which is nothing. I can also see what other variables are in my environment. So I have this bank environment, and you'll notice that it's this bank that I initialized here. And I can click into it and see what accounts it has. So I can see that, oh, hey, there's 4 accounts. Perfect, just what I created here. And they each have a balance that corresponds to the I that they were created with. So it's 1, 2, 3, and 4. Awesome. If I had more complicated data structures, you could imagine how useful this would be instead of printing out the individual instance variables and trying to figure everything out, right? Okay, so I'm going to collapse this. You'll also notice here, this is what's happening on your stack of environments. We currently have a single environment open, and it's coming from the main call, and we're currently at line 70. Okay, cool. So I'm going to take a quick pause and go back to the initial 2 points that we started with. What should I expect my code, or how should my code behave on line 70? What do I expect this to give me? I have 4 accounts with balance 1, 2, 3, and 4. What is the balance across all accounts? Just conceptually. 10, right, perfect. So the next useful tool that we're gonna go over is the step over. So if you, let's see, okay. I always get confused between the little bracket arrow and the down arrow, but if you hover over it, it'll tell you. Okay, so step over just executes a single line at a time within the current environment. So if I step over this, it'll execute line 70, and if I look in my console, it prints out that line. Expected 10, I get 10, perfect. So I can do this over and over, right? And I'm like, oh, wow, this is annoying. I just want to get to my next breakpoint, right? which you absolutely can. You don't have to do step over and over again. You can do continue, I believe, resume program. It's basically like a little fast forward button in between breakpoints. So if you were exactly where we are right now on line 73 and you wanted to get to the breakpoint at 77, you would click on this and it would take you there. It would execute all the lines in between so you don't have to manually go through it. Okay, questions so far? We're good? Okay, cool. So let's revisit those. Yeah.
It is shared.
It is, yeah.
If you go on Piazza, you'll find a link that contains a download to this.
What, it's not Piazza?
Yeah,
Where on Piazza though?
it's pinned.
Okay, thank you.
Mhm. Oh my god. Okay, so let's see. Okay, so let's go back to the original two questions again. Before we were looking for something that we expected, and we got what we expected. The last breakpoint was good. Let's do it again for this breakpoint. So what should we expect after, well, basically all the lines in between 70 and 77? Shout it out, just shout it out. Oh yeah, like what do I, after executing line 71 through 76, basically like what should be happening in my environment right now and what would I expect this to evaluate to? Okay. So, okay. Nice, okay. So there's a little bit more to this. So you might encounter this later on in your life or right now, who knows. But sometimes not all tests are written correctly. So is this test written correctly? Does it behave the way that accounts and our bank should behave? Yeah. What? Yeah, okay, good, okay. So at some point, I would expect an account to be over withdrawn, I think is like the right term, or overdrawn. And if I take a look at what's happening in account, I should only withdraw funds if it's available, right? Okay. If you see the bug already, don't say it. Good for you. But also, I want to show some more buttons. Okay, so I'm just going to step over this and see if my expectations are met. Okay, so I step over this, and I see that, I have 2 across all of my accounts, but that means that the account that had 1 in it got over withdrawn, right? So I'm going to complete executing. What?
Show them bank.
What?
Show them the bank variable.
The banks? Okay. Yeah. A negative balance. Nice. Damn. Okay. I feel like, you know how people like aren't supposed to curse on the web? I don't know. On the videos, I feel like okay. Anyway, so the way that I can complete executing or just like stop the debugger altogether is either by, again, resuming the program, or you can just stop this execution altogether. So for now, I'm just going to stop. This is really great when you've like stepped over a line that you want to hone in on, and you don't want to go through the trouble of like seeing the rest of the code execute. So use the stop button as appropriate. Okay, So now that I know that there's an issue with this test and its execution, I'm going to remove the first breakpoint and just focus in on line 77. So let's run the debugger again. I removed the breakpoint at 70. And now I'm going to step into this function call. So the way that I step into it, well, first, stepping into just means that there might be a nested call on this line, and I'm going to step into that nested call. So if I click on step into, it'll take me to the call balance across accounts. So now I can do the same thing as before, which is just stepping over individual lines and see what happens. So I know that there was an issue with the first account when it was overdrawn. So let's take a look at the, what's it called? Let's take a look at the first account, and then we might have to go back a little bit. Oh, whoops, my bad. So stepping into, we're at the second account right now. I apologize. But just for demonstration purposes, I just want to highlight that your stack looks different from before. It looks a little bit more meaningful than the stack that we had when it was just the main environment. So the way to interpret this is I am currently on the environment in the call check balance on line 46, which came from the call to balance across accounts, which was left at line 42, which came from the call in main, which was left at line 77. Okay. So let's see. I'm gonna take a pause. Does everyone understand this stack thing? Okay, yeah, okay. I'm gonna stop this execution because I went a little bit too far. And okay, well, we stopped it. Wow, exciting. So I presumably want to introduce a breakpoint at withdraw, right? So now let's go debugging again. And let's step into, oh my God, I stepped over. My bad. Ooh, live coding is hard. Okay, so let's step into, okay, yeah, we stepped into, we're withdrawing things now. Okay, so the amount that I want to withdraw is 2, because as you saw before, I was trying to withdraw 2 from every account. And right now, the balance of my current account is 1. Okay, so wow, the bug, it was so easy. How should I modify this statement? Shout it out, shout it out. Yeah. Well, they have to some relationship between balance and amount and not just non-negativeness. Okay, so we can stop this, modify this statement, and let's go back to our test. So now that we've modified the code, let's make sure to modify the test so it actually expects what we expect. So how can we modify this for the behavior that we anticipate? What? Oh, you seemed like you had an answer. Yeah.
I guess we would expect 8.
Mm-hmm.
We'd expect
We'd expect 4.
4.
Yes. Yeah, because the first account would not withdraw it, but then all the other accounts have enough funds where you can withdraw. So we should expect 4. And then the recursive method presumably would also do the same. Okay, so let's try running this. Yay, we did it. Wow. Okay. I'm going to take a pause before I get into like some of the more nuanced function, like things about IntelliJ. Does anyone have questions so far?
Can you go back to how you marked that?
Yeah. So before it was balance is greater than 0, and now I've modified it to be balance is greater than or equal to amount. Yeah.
So when you're not, like when we have the thing where we could like open the account thing and then open each balance and read the all numbers.
Yeah.
Is there a way to open all those almost without clicking on one?
Not that I know of. Yeah, that would be nice if things were like nice and flat and easy. I guess that would be like the benefit. Ooh. I don't want to advocate for printing out things too much, but like if it's better for your like debugging flow, that is one benefit of like printing out statements. You can format it the way that you want to, whereas with like IntelliJ, you're kind of set with the like format of everything. Yeah. That's a good question though. Does anyone else have questions? Okay, so what were our 2 questions from before that we kept coming back to? What was the first one? Yeah. How should it behave? And then the second one? Yeah. Exactly. Okay, cool. And then we just repeat it. How does it behave and is it actually doing it? Okay. How do I start my debugger? You right click on something. Do I right click out here? Oh, wow, you can. Okay, well that's running things. But like, where do I right click? Yeah, I can right click on the class, and then I can click on debug with arguments or without. Okay. What else? How do I set a breakpoint? Yeah, I click on a line. Okay, so does it execute that line when I... What? No, it doesn't. Okay. What else? What's the difference between this button and this button? Yeah.
So the left button.
The left one.
Runs the line.
Just runs the line. Nice.
Step into
Mhm.
what government some calls the line window.
Perfect. Okay, great. And then what about... Okay, I'm going to add another breakpoint. So what about this button? What does it do? Just continues. Perfect. Continue to the next breakpoint. And what about this? It just stops. Yeah, it's the name of the button. Perfect. Okay, great. So you guys, yeah.
The button next to step over, can you use the down arrow in that line? Could you get rid of the button?
Wait, this one?
Yeah.
Okay, yeah. So step into, it looks for nested calls on that line. So notice that there's a call to print line and a call to balance across accounts. So order of execution, balance across accounts will get executed first. So when I step into, it'll take me to that execution. Yeah. Oh, and fun thing, if you're like sick of seeing this method execute and you just want to escape from it, instead of like clicking step over and over again to get out of this nested call, you would just click step out to get out, and then you can just continue executing as before. Okay. Cool. Wow, you guys are like experts already. Okay, so I'm going to show you like 2 more flavorful things, and then we're gonna get to like hands-on debug things. Okay. Ooh, things and stuff and things. Okay, so let's continue. So if I step into this iterative function, I can set conditional breakpoints. Okay, so say I'm here, and it might be more helpful if I show you the recursive one, because it's a little bit hard to set a conditional breakpoint for like specific accounts. So let me just do that. So let's focus on this first recursive call. Let's go in, wham, bam, and we're going in. All right, okay. So a conditional breakpoint is exactly what it sounds like. I have some condition. If it's met, then I'm going to pause. If it's not met, I just continue. So if I wanted to look at this call when I is a certain value, I would do this. So I would first put down the breakpoint, and then I can right-click and set a condition. So maybe I only care about when I is equal to 3. Okay. And then if I continue, the next time that my code stops is when I is equal to 3, and then I can examine my environment and do whatever I need. Okay. Another fun thing, and is very closely related to the conditional breakpoint, you have this little calculator button. Okay, so you might be wondering, like, what could I need to calculate? Right? Good question. So you can do very simple things like I plus 3, and then evaluate it. And like, wow, it's 6, who knew? But you can also do like crazy things like I, and then like, I think this is like some bit operation. Yeah, fun. Ooh, challenging. Or you could do things like maybe I want to access the 0th account and then get the balance. Where is it? Check balance. And then add 45 to it because that's what I'm caring about right now. And it'll give me exactly that. Okay, yeah. No, yeah, so that's a really great question. You can also look at like objects and poke around wherever you need. That's really great, yeah. Yeah.
So if the expression I want to calculate is 2 values, store it.
Oh, yeah. Oh, let's try it. Like, int j is equal to 5. J plus 5. Let's see if this works. Yeah. Oh, it does. Okay, yeah. So I think you can actually do like a full block of code, and like just execute it. Yeah, that's great.
It can you can modify any objects as well. It's running actual Java.
Yeah. Cool. Fun stuff. Okay. Questions? Yeah.
So you can modify it. Does that mean you can like reset what it counts as in this?
Absolutely, you could.
Okay.
Yep.
Let's see what happens.
Permanent change
Oh God. Oh God. Null pointer exception. Fun.
is that a permanent change?
It shouldn't be. So if you like executed this henceforth, like you'll see accounts as a non-null object. Yeah.
It's for the current running of the program.
Yeah. Cool. Yeah. Yeah, so if you right-click on the breakpoint, you can set a condition for it to stop at. Yeah. Great, awesome. Other questions? Okay. I thought I saw a hand. Okay, wow, exciting. You're on your way to being excellent software engineers. Okay, and now Ross.
Okay, cool. Yeah. So Lisa covered the basics of some of the functions of IntelliJ's debugger, and now you'll get a chance to play around with them and try to solve a couple bugs in a buggy linked list implementation I wrote. So first, I'll just point out that if you want a quick reference, if you go onto the Debugger Workshop page, there's a handy reference sheet that tells you about the buttons and gives a quick little description of what each one does. So you can go look at, for example, the difference between step over and into. So here's a reference if you'd like to have it while you're working through the code. It's available on the notes. So let's dive into the code. So y'all have a class called Buggy Linked List. It's a simple implementation of a linked list with 4 methods. It's double-ended, so you can either add to the front or back, and then you can remove from the front and back as well. So in this code, there's no tests currently. So the first thing you'll have to do is write some simple unit tests to see how this linked list works, call some methods, add some stuff, remove some stuff, and try and find where it crashes. There's two functions in here which contain bugs, such that with the right sequence of adding and removing, you will... sorry, correction. There's only one crash. So one of these functions will crash outright if you call it. And the second bug is the function doesn't actually do anything. So I'll just give those hints. One bug is crash. Second bug is function does nothing. And your goal is to find each of these bugs using the debugger. So first you'll write some tests, then step to them with the debugger, see if you can find out where it crashes, and then fix them. We'll give you some time to do that now. You're welcome to partner up with the people around you and try it out. We'll come around and answer questions if you have them. Yeah. Yeah. Yeah, I mean, either one's fine. The little dots just mean it's embedded breakpoint. That's all. But really good. I totally realize there's a bug in this main method now because it's creating a linked list, which is not actually the class you are given. So to test this code, you want to use a buggy linked list. Just add the word buggy in front. Thank you for that catch. Yeah, and then we don't need this. That would be important. These will make the bugs very difficult to find. I'm sure Java programmers have thought about it. Mostly through That's correct. Yes, that's actually our fault. We did that by design because we wanted to discourage people from accidentally opening individual files as opposed to folders. So we just said, if you want to open button, start. And then if you want to open things in the previous one. But yeah, that's the solution. It's close it, open it once, and then you can get it. Yeah. Thank you.
No, I'm not going to ask a question about auto-completer. Work. I didn't know you had access to
Yeah, try it.
And then write some tests for it and check if it actually.
You should be able to come up
And
with
then that'll
some
give you
simple
a
cases
Okay.
where like a crashes word function.
Yes, because the one time that doesn't do anything. It's not fun.
Okay, and then
That's
So
that's
what does a breakpoint exactly do for a debugger?
Does it not?
Yeah, so
Well, I
like
put-
for
I changed
example,
the to make it do something.
the
What does it do right now?
debugger will stop
Originally,
right before
It creates
the
a
line
it sets.
So it's basically like pausing.
Oh, wait. It doesn't work.
okay.
And then sets head equal to head. So head is the
How are you
represents the front of the
Alright.
Right. The hand.
Alright.
Right.
Right. So we want the hand.
Okay.
You should
To say it's not supposed to happen. So when we add
Oh,
the
okay.
new
So
item, we make that
again,
item.
I would start off
We make
with
that new
writing
item point to
tests.
the open.
And
Correct.
then
Yes.
using
That's
that
what we should
as
do
a
here. Like on that mesh, we do it. That's what we done.
If you try it out in the
And then we
debugger,
make the head equal to
you'll see that it does modify it.
Yeah, so under certain conditions, like certain, like if my linked list had like some number in it,
So you,
or like
yeah, so
there's
what
a
you
certain
do
length,
is
then it'll
just
just
like typically you should set
Yeah, that's what's
the
so funny.
function where
Wait,
you can
Doctor
step
Lisa,
through it
why
and then
why do we can't add back this way and just like backtrack? Is this thing gonna take more
do you
time?
have a unit test that calls that from?
It is contrived
In order for that
examples
function
for
to get called, you
learning.
need to make a test at the bottom.
No, that's not good. If they would yell at us for this. This takes too
Yeah,
long. This
no,
takes linear time.
And then change
Yes, that is true, but for the sake of this exercise.
I mean, it also helps you not get fired.
Yeah.
I wasn't there.
You
Oh.
this. You can just use this for
That was
Yes,
Oh,
it wouldn't come up with any bugs.
Yeah, I mean, we wanted like
That's
an
no-
example that was vaguely applicable to what you were working on for this week's assignment, but we
Vaguely,
didn't,
this is very helpful.
but we didn't want you to like have a working solution of this week's like assignment, right? So yes, you are right, this is inefficient, but for the sake of this exercise, take it as it is. Pointers are weird. Include some tests. Figure out.
The head is.
I'm gonna adjust it. Hello.
And now your head is the modifier.
Yeah, I know.
And
Okay.
you can confirm there's the same object, you can this number.
Oh,
But that's six bullet points, just another one, and six bullet points.
That's right. Yeah, the memory element.
Huh.
I like this.
Nice. It's very handy.
It is very handy.
Yeah. Alright, so you can find
So I think you might
Also, when you look with the assignment, you can't use the wiring loops. Because
Oh,
each method must be,
Oh.
yeah.
must be constant.
So now.
any question.
So you can't always run this thing, like you have to have some code established or something. Because when I had that jaded accident,
Okay.
I wouldn't see this.
Oh,
I
okay.
wasn't even able to see that, so.
Right. So it's like think about just like executing the code. The debugger is stopping you at certain points of the code execution. So if your code does not compile, it will not get to the execution
Oh,
stage.
so it's first thing.
Yeah. So always compile. If it doesn't compile, then you fix the compiler errors.
So we
And
can
then
do
you're
one.
executing.
So you have added
Breakpoints.
pages.
So we should add, we should do, right?
I will. So, you know,
That stopping thoughts I have, that's like, wow,
you took that.
and how often
Nice preparation.
Thank you, it was a sprint to
I
finish.
that.
color-coded notes. But you don't have color-coded notes.
I
No, you're never gonna. You listen to Wall.
Oh, you did?
Wall is great. Okay, wait. Why does it have to unload and
it actually doesn't matter where you place it. Yeah, that's because I didn't declare public.
Why don't you set next to null?
Because by default, a reference is null.
Oh, so we also I didn't even have to set it. So when I put I didn't have to set it to null if it follows 226.
Think about like what it chooses.
Sure, yeah. Yeah, you can use default values. For instance, any primitive.
If you don't want, okay.
Like intro.
Wait, yeah, so I need to generate my like things. Yeah, don't even make sense. Don't imagine this is the worst. But yeah. Wait, so so like I'm going to like do I have to make if these as nodes or something?
What other
thing, so it creates a node. Then I can't access that node. There's like no way. So I can't get access. I'm trying to do the cross. It's like the worst. And then it has a node with that value.
Well, that's what the debugger is for. The debugger will let you step into the code and check out that node when it's created.
Wait, how does the debugger
Well, because the debugger lets you step into the functions where you do have access to the relevant variables. So if you want to see the node being created, you would step into the function where node occurs, where it creates it, such as at the function. So try, you have a good unit says here that, okay, so it calls add first and add last. So then you can start by either putting the breakpoint in the game, or you can put it up in the function you care about. Add first.
Alright, yeah. I want to get the result of that. I want to get the result of
So yes, I did not include any function which gets the output from the list. You can only add things to it and remove. So if you want to inspect the list, you have to
go for it. There's like
That's
by design.
I want to see
Were you the one who wrote
Yes.
these numbers?
I
Wait, so how do I put a breakpoint?
How are you
put
doing?
a breakpoint by
No! Be life. Okay.
These are what these are.
Alright.
Yes.
Okay.
How come nobody's told me this?
Ooh.
No, but like, wait, so what is this gonna say? Is this gonna print this out?
So what will happen is when you run the debugger, go ahead, try running.
Alright, Ross.
Oh, wait.
I debug.
Oh, wait. Never mind.
I'm gonna use this one debug.
So, no, you're doing fine. You're from the back when there's nothing there. It should just not do anything. Okay. So actually, I think this is good. So let's take a look what this message is on. So this is saying there was an exception that was adding to the track.
Why did you do that then?
That was an unintended bug.
Oh, great. Oh, great.
Possibly
So when the assignment on bum, you went
so this might be
Yeah, so James Book was typing in
as is the line.
This is going to be a great story for what I thought it comes to. Okay. Oh, great. It doesn't even have to add this to add
Just
oh yes, the name's changed to add.
Why? You just couldn't really be different.
Because I did not consult the reference.
Well, I don't know if
Let's
you
try
use
running
API, Ross.
or running the
That's disappointing.
click on the little bug.
Now try running.
Well, I can compile.
Yep.
Yeah. So step around and see if things are behaving the way that you expect it to behave. That works. Okay.
There we go.
Yo, this is so beautiful.
Yeah. So
Now you
this
can
is
see the-
instance variable.
the code is like separate.
And
So
this
that
is
is
an
actually
example
right. If you
of
provide
a
exception,
linked list
it
that is
is
initially
empty,
set up.
then we just make close.
So what's this?
What do you just?
So those are all the variables that you have access to that space. So you have access to the item that came from the parameters.
Or,
Anything else in the buggy linked list, such as the end.
What is that?
So that's everything you can see from that function.
where for this map is coming from?
Oh, this then.
Oh, yeah, yeah. So this is just saying,
Okay, so I've.
that node is
So see if you can find the bug now.
visible
Alright,
inside
see you
that
next week.
contains this class, but that's fine.